Hey there and welcome. By the end of this video, you will be able to solve multi-step equations using the traditional method. Let's go ahead and get started. Alright, so multi-step equations tend to take 3 or more steps to solve. That's why they're called multi-step. There are multiple steps to them. There are many different ways that this can look, and we're going to go over 3 of those different ways. So there's the traditional method, the hanger method, and the box method. For this video, we're going to go over just the traditional method. Now, I want you to choose whichever method works best for you. It's okay to change which method you choose to use later on, or depending on what the problem looks like, right? That's totally fine and completely your choice. These are just options for you so that you can choose the one that works best for your learning style. The following problems that you're going to see are also just sample problems and are not the only types of problems that you're going to see throughout your years of school. But there's just way too many to be able to fit into a video. So do the best that you can with all of those others, but let's look at a couple here. So if we have this problem 6r plus 7 equals 13 plus 7r, you're going to notice that you have variables on both sides of that equal sign. I've got 6r on one side of the equal sign, I have 7r on the other. Now, the way that I personally like to do it is I like to take my smaller variable and move it to the other side of the equal sign. And the only way to do this is with inverse operations. So 6r is smaller than 7r. So the only way to move it is to take that positive 6r and subtract it. Right? The inverse of that positive is the negative, and I need to take the r with it. So I'm not going to divide. I'm not trying to separate those two things. I'm trying to move the entire thing. So I'm going to subtract 6r from both sides. When I do that, I'm left with 7 on that left side equals 13 plus 7r minus 6r is just plain r, or 1r if you wish. From here, I'm going to use my circle of don't touch, which is that r. I know I have to get rid of that 13, so I'm going to subtract 13 from both sides. And then 7 minus 13 is negative 6. So r equals negative 6. I can go back through, I can check my answer, make sure it's good, substitute that negative 6 in everywhere that I see an r in the original problem. You end up with negative 29 equals negative 29. All right, for our next problem, this time I have 2 x's on one side of my equal sign and then 1 x on the other, and that's totally fine. All right, I have negative 7x minus 3x plus 2 equals negative 8x minus 8. The first thing I'm going to do is I'm going to take those like terms which are on the same side of the equal sign. Like terms have to be on the same side of the equal sign. I'm going to combine them together. So negative 7 and negative 3 are going to give me a negative 10x plus 2 equals negative 8x minus 8. Again, I'm going to take my smaller x value and move it to the other side of the equal sign using inverse operations. You don't have to choose the smallest one. I just like to because I'm less likely to deal with negative numbers. So negative 10 is smaller than negative 8. So the inverse of negative 10 is positive 10. So I'm going to add 10x to both sides. Don't forget your variable. They're stuck together. Right? Adding and subtracting does not unstick them. So when I add 10x to both sides, I end up with 2 all by itself on that left-hand side equals negative 8x plus 10x is a positive 2x minus 8. I'm going to use my circle of don't touch here, which is 2x. So I'm going to keep that where it is. I have to get rid of that negative 8. So the only way to do that using inverse operations is to add 8 to both sides. I end up with 10 equals 2x. Going to divide both sides by 2, and I end up with x equals 5. I can check my answers. I just need to take that original problem and substitute the value that I got for x. We said x was 5, so I'm going to substitute 5 in every single time I see an x, which is 3 different places this time. And at the end, I end up with negative 48 equals negative 48, which is a true statement, so I know my answer is correct. All right, again, those are just a couple of the possible examples that you will see, but for this lesson, we learned how to solve multi-step equations using the traditional method. Until next time, I will see you later. Love you, bye.